I'm Adolph Oliver, and this is the video clip on excluded values and rational expressions. Now, remember, rational expression is just the official term for what I like to call algebraic fractions. In other words, fractions that have some variables in them. And kind of like this example we have down here that we're going to be looking at pretty quick. Well, here's the problem. If the denominator of the fraction equals 0, the fraction is undefined. Just think of something like this. 5 over 0. Okay, since we got a 0 downstairs here, then that means that the answer to this, well, most folks just call it undefined. Okay, or it's also known as equaling infinity, that kind of lazy sideways 8 like that. Well, we can't have any downstairs equal to 0 because an undefined or infinity value is impossible to write down. So here's what happens. We have to check the downstairs of our algebraic expressions to see if there's a value of x that will make this downstairs equal to 0. Later in your math, you'll learn how to do some more complicated analyses with something like this. But for the time being, we're just focusing right on the bottom. So, okay, let's show you what you do here. Since there's a variable down here, there'll be a variable value of x, which will make this downstairs 0. And if this was in an equation, we could not allow that to be one of the answers. This is where your factoring comes in. Okay, we got to factor this to a single term, and notice there's a common 3, so I can factor the 3 out, and the leftover is x minus 2. Now, of course, remember, anytime you factor out a GCF, multiply it back to make sure that you've got it correct. 3 times x is 3x, 3 times negative 2 is negative 6. Now it's a lot easier to see what value of x will make this downstairs equal to 0. This is just like finding the roots in a quadratic equation, because here's what it is. We want to find out what values of the variable cause this to happen. Well, it's pretty easy to see that the value of x here that'll make this x minus 2 equal to 0 is just 2. So what we'd say on this is that x cannot equal the value 2. This would be the excluded value. Finding excluded values is not a difficult thing to do. Okay, let's look at some examples here. Here comes a first one. And again, remember, it's not the top that we're worried about. If there's a 0 upstairs, 0 over 5, well, that's perfectly fine. The 5 downstairs makes the denominator good. We just have 0 parts of that 5. So something like this could just be written as plain old 0. Well, okay, once again then, what we're just looking at is the guy that's downstairs. To factor this into a single term, there's no GCF here, so we put parens around it, and that makes it a single term. And what value of k would make this 0? Well, k, if it was negative 3, this would be 0. So we say in this one, k cannot equal negative 3, because if it did, the downstairs would be 0, and the value of this fraction would be undefined or infinity. Well, okay, some are pretty easy to look at. Here's an example where we already have single terms top and bottom. And again, for excluded values, we're only worried about the downstairs. Well, we see the variable r here. What value of r would make this downstairs equal to 0? Well, just r equals 0. Okay, if r equals 0, 0 to the 4th power would be 0. 60 times 0 would be 0. The downstairs would definitely be 0. Well, okay, that tells us then that our excluded value here is r cannot equal 0. Now, sometimes you have a case like this third guy right here. Remember again, for excluded values, we're only worried about the downstairs. Well, notice that the downstairs doesn't have a variable in it. It's just got the number 14, and that's going to be 14 all the time. It's never going to change. So since there is no variable down here, okay, then that means that we have no excluded value for this one. Okay, well, remember this excluded value business is something that only occurs when we have variables downstairs in an algebraic fraction, or rational expression as it's officially called. Here's another example. And again, as always, for excluded values, we're only interested in what's happening downstairs. Now, how do we find the values of m that'll make this 0? Well, what we do is we factor it, and then it's just like finding the roots of a quadratic equation. We find out what values in those factors will make the downstairs 0. Well, let's just remind you. We got to factor this. Notice that we have a nice +1 in front of the m squared. Okay, so we can use our old reverse FOIL techniques. So I can start setting this up. I'll have m's at the start of each one of the binomials this multiplies to. Now, the plus here, okay, means our choices are either double plus or double minus. Remember, we always look at the sign of the last term, and it comes from multiplying two numbers together. The only way you can end up with a plus is if you multiply two pluses or two minuses. Now, hopefully, remember, it's very easy to figure out which one to do. You look at the sign of the center term, and whichever one that is, that's what you do. The center term is negative, so that reminds us then that this is a double negative. Okay, here it is. Now, the two-number game. I want two numbers that give me 36. Remember, the plus here means I also want the sum of those numbers to be 13. Well, what two numbers multiply together give me 36, whose sum is 13? How about 9 and 4, I think, huh? 9 and 4. 4 times 9 is 36. The sum of 9 and 4 is 13. Okay, there they are. And of course, since the signs are the same in both of the binomials here, it doesn't matter where we put this. They'll both be behind minus signs. So let me just write this as m minus 9 and m minus 4. And again, what we're doing is saying, okay, what values of these m's will make either one of these guys 0, hence make the downstairs 0, which means it's undefined. Well, okay, m minus 9, this is just like finding the roots of a quadratic, positive 9. 9 minus 9 would be 0. The downstairs would be 0. Likewise here, m minus 4, positive 4. 4 minus 4 would give me 0. The downstairs would be undefined again. So the excluded values here, we'd say m cannot equal either 4 or 9. These are the two values which would make the downstairs undefined. Well, okay, one last example. You got the idea of how it goes. And of course, factoring plays a big role here in helping to get all of this solved for us. Okay, once again, it's the downstairs that we're interested in. We're not worried about the upstairs at the moment. We're just trying to find values of the variable which will make this undefined. And that again means values of the variable which make the downstairs 0. Well, the first thing notice here, I think there's a common 3 that we can factor out. So if I factor 3 out of 3x squared, I get x squared. Factor a 3 out of minus 6, I get minus 2x. Factor a 3 out of 144, I think that's 48, huh? So minus 48. Okay, let's double check. 3 times x squared is x squared. 3 times negative 2x is negative 6x. 3 times minus 48, let's see, 120 and 20, yeah, that's correct. Okay, now we got to factor this guy. Okay, again, he's going to be a nice little reverse FOIL. Notice that in front of the x squared here, there would officially be a plus 1. So this can be factored. Okay, we're going to factor it into x and x. Now let's get the signs before we get too far. Notice the minus here means the signs are one of each. What I mean by one of each is one is positive and one is negative. You multiply a plus and minus together, you get a negative, and that's how come the last term is negative here. So plus and a minus, put them wherever you feel like. Remember, we're going to do something to get the numbers in the right place in just a moment. Now, while we're looking at this, let's remember we bring down this 3 because it was factored out earlier. Okay, here we go. Play our two numbers game. I want two numbers multiplied together give me 48, whose difference is 2. Yeah, how about 6 and 8, huh? 6 and 8. 6 times 8 is 48. And the difference, remember, the minus here means I want their difference to be the 2 right here. So 6 and 8, the difference is 2. So these are the numbers. Now, you have to be careful when the signs are different. When we got this one of each situation. That's when you play what I like to call the bigger game. 6 and 8, who's the bigger guy? The 8. So take the bigger guy. He has to have the sign of the center term. Well, the center term is negative. So that means the 8 goes behind the minus wherever I put it. Where did I put the minus? Oh, I put it right here. So here goes the 8. And then the 6 goes in the other hole. Okay, once again, what we're doing here is trying to figure out what values of the variable make either of these guys 0. Well, right here, if x is negative 6, okay, that will make it 0. Negative 6 plus 6, 0. So that would be a bad value, an excluded one. Right here, positive 8. 8 minus 8 is 0. Okay, so these are the two values of the variable x that we would not allow in this original expression. And so we could say something like this, simply x cannot equal negative 6, comma 8. Those are the two values we would not allow. Okay, well, once you know how to do it, finding excluded values is not a difficult thing to do at all.